It's Mr. McQueary here today, and we're going to talk about scientific notation. Now, there's a few things we're going to cover during this lesson. Number one, what is scientific notation? Why do we use it? And then we're going to hone some skills that we can use to convert numbers to scientific notation, and then work backwards where we take numbers that are already in notation and convert that back to standard form. So there's really four big things we're going to cover. All right. The two big skills we're going to cover here, like we said, are converting measurements to scientific notation, and then flipping it on its head and converting that back to standard form. At the bottom of the screen here, you can see kind of our end goal here. So when we try to do that first learn target of converting measurements to scientific notation, we want it to end up like this number here at the bottom, this whole thing right here. And it's divided into three different parts. You have the coefficient, all right, you have the exponent, and the base. Now, lucky for us, everything we're going to do this year is in base 10. Okay, that's your powers of 10, your metric system stuff comes into play. We're going to keep it in powers of 10. So whenever you do this, all you got to worry about is the coefficient and the exponent. So that makes things a lot easier for us. All right, so let's go ahead and let's get started. Let's see what we're getting ourselves into today. All right, well, why do we even bother with this, right? Why don't you look at those numbers? Okay, we have a number over here that's super itty bitty. That happens to be the mass of a carbon atom to kind of give you a perspective. So we're talking itty bitty bitty. On the right here, we got some enormous numbers, all right? And this year, when we talk about space, we start getting into the cosmic numbers. I mean, these things are absolutely enormous. This happens to be the distance from the sun to Neptune. They kind of give you an idea. And we're going to study things that get even bigger than that, all right? So on the surface, neither one of these numbers look very friendly, all right? There are a lot of zeros involved here. There's a lot of places where maybe if we're going to be writing this out several times in maybe a lab report or working through problems, it's easy to forget a zero, to add a zero, or maybe you're just tired of writing, right? It's a lot to put in your calculator, a lot to write on your paper. And this year's going to be full of little tips and tricks where we try to make life easier for you, all right? That's kind of my goal here. There's a guy, well, he's not a guy, he's a duck, Scrooge McDuck, who said, work smarter, not harder. And I can't do his Scottish accent justice, but it goes along something like that. And that's my goal here for physics. We can make this thing really difficult, or we can try to simplify this and really get to the meat of the issues that we need to be focusing on, right? So we're going to have enough trouble this year figuring out what formulas to use. We're going to have enough trouble trying to figure out what are our problem-solving strategies. We don't need to worry about giant numbers, all right? So we're making life easier for ourselves, all right? So here's an example there at the bottom, and I'm going to keep that on just about almost every slide here for the first part of this PowerPoint, just to kind of give you an idea of what our end goal is supposed to be, all right? Now, this number over here, this number on the right here, neither one of those are very friendly, right? We want to make those something like this. See, we can write this out, right? 4.1 times 10 to the fourth. That's a lot easier to write, right? And these have just so many extra zeros that we don't even know what to do with, right? So we're going to try to convert those into this finished product scientific notation, okay? And you can see those are two examples right here. A number that's much, much smaller than 1. That's a candidate for scientific notation. And we have a number here that's much greater than 10. It's a lot bigger than 10. That's another good candidate for scientific notation. All right, so let's work with those two samples for a while. All right, step number 1. All right, if you notice up here in the top right corner, all right, this coefficient, there's only one number or one digit to the left of the decimal, and that's where we want to be. Okay, right now, this number here on the left has one number to the left of the decimal, but unfortunately it's 0. And we can't use 0 with this. It's got to be number 1 through 9. Okay, so that 4.1, 4 works. 0 over here, not going to work. On the right-hand side, we know that our decimal is really supposed to be here at the end on the far right of that last 0. And there are a lot of numbers that are built before that zero or before that decimal. And we can't use any of them, right? Because that is a number that's much bigger than 9. So we only can have one number before the decimal. So we're going to go ahead and move that over. All right, so if I'm over here on this left-hand side, we're going to move that decimal all the way over here to 1. We'll start over here. We'll move our way across. If you put it between this 1 and the 0, now we have a number that looks kind of like that, where there's only one digit to the left of the decimal. Okay, that's good. On this side here, our decimal, we got to keep moving over here until we've only got one number before our decimal. So we're going to go all over here between this 9 and the 6. Okay, remember, we can use 9 in front of our decimal. We can use 1 in front of the decimal. So we're in good position with both of those. All right, that's the whole first step. Not too bad, right? We just move a decimal over a few times. So now we're left with these numbers right here. And those are a lot more doable, okay? That, as a matter of fact, these would be the numbers that we are going to plug into that coefficient part. We're going to plug those right in, plug and chug, all right? Now, the second step is trying to figure out what is the exponent here going to be. Because so far we have the coefficient figured out. It's this guy and this guy. We told you it's always going to be 10. So we're almost there. We've got to figure out what's that exponent going to be. All right. So over here, you can see the original number. We moved it 6 spaces to get where we wanted it to be, where it was that number we could use between 1 and 9, only one number to the left of the decimal, that good stuff. We moved it 6 times. On the right here, we moved it 9 times where we wanted it to be. Okay. So that number, the number of times we moved it, is going to be our exponent. All right. And usually that's not something that students have trouble with. They can move the decimal, they can count out 1, 2, 3, 4, 5, so on and so forth. It's usually the positive and the negative that gets them. All right, when we talk about the sign of your exponent, that's usually what gets you. Okay, and there's 2 ways to do this. One of them is to say, hey, look here at the decimal. Okay, we moved it to the right to get where we wanted to be. That means that your exponent is going to be negative. That's where that -6 comes in. Likewise, if you're on this side, you start from the decimal and move to your left to get where you wanted to be. So we're going to call that a positive exponent. Some people like that. All right, if you want to have that kind of that tool in your mind, you can use that. Personally, I think it gets confusing when we ask you to take scientific notation and go backwards to get to standard form. Because then you're flipping and flopping, and there's all sorts of positive, negatives going on. Here's how I like to think of it. All right. This number over here is pretty small, we agree, right? It's super small. And if it's tiny, we're going to say, hey, tiny numbers are going to have negative exponents. All right. This number over here is a pretty large number. All right. Huge numbers are going to have positive exponents. That's easier for me to remember, looking at the original number and trying to figure out was left positive or is right negative, but you do you. All right, we're giving you a little bit of choice on this one. So let's work through this. Basically, this is fill in the blanks, right? We've got our coefficient here, which we've already found. That's our number that only has 1 digit to the left of the decimal. And then over here tells us how many times we had to move the decimal over. And we just plug it in and we're done. All right. So in our first number, we agreed that we moved our decimal over here. And we're going to bring that straight down. Copy and paste. Okay. Now we end up moving it 6 times. And we said it was a -6, right? Because we moved it to the right. Or if you're doing this McQueary method, you said it's a small number, right? So that plugs in -6 right over here. Okay. So far, so good, right? Let's finish that second example. All right, second example, we moved it all the way over here, that decimal all the way between the 9 and the 6. We're going to bring him down. And then for our power, we said we ended up moving 9 times. Okay, we moved it to the left, or you could say 9 times, and it's a big number. 9. And that's it. All right, so that's our first skill right there. We've taken numbers that are in standard form, and we've moved those over to scientific notation. All right, now we're looking at practice now. Let's do these real quick. Okay, we won't spend as much time on these. Our decimal's over here. We move it between the 3 and the 6. So we have 3.6. Now that second part is going to be times 10 to the, well, let's see, 1, 2, 3, 4, 5, 6. We moved it 7 times to get there. To the left, it's a big number. We'll keep it positive 7. All right. Likewise down here, 1, 2, 3, 4, 5, 6, 7. So now instead of positive 7, we're going to do a negative 7, right? Because we went to the right this time, and it's a small number. Right? And the number we're going to put first is this 2.56. How about that? All right. Now the very last thing we're going to do here, look at this 212 thousandths for our math people. We're only going to move this once, right? And it went 1 place to the right. So that's where our -1 comes in. That's where our 2 and 1200ths comes in. All right. So far, we're going at a pretty good pace here. If you need to take more time, you can go ahead and replay this. No shame in that. All right. In summary, we've got a coefficient, we've got an exponent as part of our scientific notation. The coefficient can only have one number before your decimal, or one digit. Exponent here is the number of times you've moved that decimal. And then this is some Mr. McQueary method down here. If it's a big number, it's going to be a positive exponent. Small number, it's going to be a negative. All right. So that's the first half of our lecture. Second half, so we flip this thing. All right. So now we're going to give you scientific notation, like this guy on the left and on the right. And we're going to ask you to go back to standard form. Now, one thing that I didn't say in the first section is that standard form is kind of like your counting numbers, right? Think of like 123,000 or maybe 42, right? Those are in standard form. There's no, exponent or 10 to the power or something to worry about. All right. So you're going to find out that going this way is a little easier. Okay. And it goes something like this. See this little power of 4 right here? See this power of 3? Okay. That's the amount of times we're going to move our decimal. Okay. So in this case, we're going to move 4 times. Now the only question is which way it goes. Do we go 1, 2, 3, 4? Or do we go 1, 2, 3, 4? Right? Well, let's go back to the Miss McQueary method here. Think about this. 10 to the 4th tells me that's a big number, right? If I move this decimal to the left, I don't get a big number, right? I get a small number. If I move this thing to the right, though, now I got a big number. So we're going to move this thing to the right. 1, 2, 3, 4. All right. There we go. 32,838, which just so happens to be Kenny Anderson's career yardage mark as a Bengals quarterback, which is a franchise record. All right. Now, on our example here on the right, I have this negative number. And we know that negative numbers for an exponent typically mean a small number in standard form, right? So we're going to move this guy to the left. 1, 2, 3. So our decimal ends up way over here. And we've got 2 blanks over here. These are our placeholders, right? Because we can't just leave them blank. All right. We're going to fill those in with zeros. All right. Because this number is different from this number, correct? All right. This number is larger than this one. All right. So we have to be very careful on that. Let me just bring it straight down. And we're done. All right. So feel free to ask your parents or maybe your grandparents on the significance of these numbers right here. They might recall maybe some songs from their childhood. All right. Let's do a quick practice problem here to kind of get us, the right direction. All right, so we've got 10 to the 7th. That's a big number, right? So let's move it over here to the right, make that number big. We've got 20 million, which so happens to be the amount of money we paid Spain after the Spanish-American War for territories like the Philippines, Puerto Rico, Guam, Cuba. A little history in that number right there. Now this number over here, we have 7 times 10 to the negative 3. We're going to move this number to the left, right? So we're going to go 1, 2, 3, right? Because we're making a small number because of that negative exponent. And it's a good excuse to include old 007, like James Bond, right? Now on this bottom number over here, we have 1.2 times 10 to the 5th. That positive 5 means we want to have a big number, right? And big numbers mean we go to the right. 1, 2, 3, 4, 5. 120,000. All right. So that about wraps us up here for the day. I hope you enjoyed this video. During it, we were able to figure out what is scientific notation, why do we use it, how to convert to it, and then how to convert back to standard form. Till next time, see you later.